Hi guys, another higher exam questions quick revision. It's just a couple of questions. Both of them are quite detailed, but fortunately for you guys, they're my favourite kind of sums. So I'll try and explain it as easy as I can. So A is a point with coordinates 7 and 13. Remember, this is our x and this is our y. B is the point with coordinates minus 3 and 21, and C is the point with coordinates 15 and 23. M is the midpoint of AB. So if M is the midpoint of AB, we need to find the coordinates between A and B. And to do that, we do this. The midpoint of two coordinates equals add whatever they are, the parts, divided by 2. So for example, this is our A to B, agreed? So we have M equals 7 plus minus 3. So that's 7 plus my minus 3 divided by 2. And the other one is going to be 13 plus 21 divided by 2. So there we have it. That's all our information. So now we can solve it. And you've got a calculator, so I won't go on. So the answer is 2 and 17. They're my coordinates for M between A and B. So the next one, N is the midpoint of BC. So this time we're going this way. So now we've got N equals what we've got. We've got minus 3 plus 15. And we also have 21 plus 23, all over 2. Pop that all into your calculator, and your calculator will spit out 6 and 22. So there we have it. That's your first point of this three mark question, which, to be honest, it's pretty straightforward. So the next one I'm going to do, because I've done this now, that's all dealt with. It's asking me to work out the distance between M and N. Now, to work out the distance, this is where you think, distance. We're going to use Pythagoras theorem, Pythag as I call it. Or to work out the distance, you could just think of it as distance squared, x squared plus y squared. You could just think like that. You could think x squared plus y squared. This is aimed more at the foundation kids. Higher would know straight away what to do. But for a foundation level, all you're doing is plugging in your information. So to find the distance of M and N, because that's what it's asking us. So M and N. I'm not saying M and M. It's MN. Sorry. I'm going to square root our x and our y. So let's have a look. What you have to do there is our x and our y. So we're going to take 6 minus 2 equals 4. So that's 4 squared. Well, plus. And the next one is going to be 22 subtract 17 equals 5. So obviously, there we go, I'll pop that there. And 5 squared. Remember, you've got your calculator, you could just put all this in. Then you get square root of 41, which gives your answer in 1 decimal place, because that's what it's asking us to leave it as. 6.4 to 1 decimal place. There we have it. So if you're on a foundation and you've got through even this bit, well done you, because there's a lot of thought that needs to go into it. Hopefully I've explained it as simply as I can. And then anything with a distance, just think squaring and a bit of Pythag. Okay, but as I said, if you're on foundation, well done to you. So the next one, prove algebraically that 0.0723, ignore that, can be written as 241 all over 3,330. So it's asking you to prove 0.073 recurring can be written as that. And this is your answer. So you're actually showing how you get this answer. So we'll write it as x equals for now, because we don't know the correct answer. Okay, so there we go. Now I need to get rid of these recurring decimals because there isn't any there. And to do that, I'm going to multiply it by 10,000. So if you multiply this by 10,000, you are going to move the decimal places and it will look like this. So if you pop that into the calculator, you'll get an answer like this. But I've still got recurring decimals. I can't do anything with that. So what I'm now going to do is I'm going to times this with 10, which will give me 0.723 recurring. So now I know I can cancel them out. So by doing that, I'm going to make it into a subtraction. This is just how I do it. Your teacher might not do it like this, just how I do it. So if I subtract this, so I'm going to get 9,990x here. And here, we have now got rid of our recurring decimals. And we have 7, 2, 3. See, now it's starting to look like this. So let's do it. Let's do x equals 723 all over 9990, and we're going to simplify it. Pop it into the calculator, and there we have it. So you just proved that this can look like that. So just remember, the concept is you need to get rid of these. That's what you need to do. You need to get rid of the reoccurring numbers. And once you do that, you can solve it. Now, you will get these on foundation papers, but it won't be as hard as this, and you won't have to move so many numbers. Yeah, this is probably as hard as it gets for these questions. Hope you understood it. Bye-bye.